Hopefully if I do 16, you'll figure out 17. The angle is drawn in such a manner that its initial side lies on the positive x-axis. So here's its initial side. And its terminal side passes through the point 4, -7. And so you go right 4 and you go down. And you're at 4, -7. All right. Now think about how this triangle would be drawn if there was a triangle there. We'll just throw the angle in the corner. You went right 4, you fell 7. You do one of the oldest theorems that we as a species have, Pythagorean theorem. 4 squared plus 7 squared is c squared, because we don't square negative. When a negative squared is positive. That's 16 and 49, which ought to be 65. So c is root 65, and hypotenuses are always positive, because Pythagorean theorem makes it so. And now you think about good old SOHCAHTOA. The sine of this angle is opposite over hypotenuse, so -7 over root 65. And you multiply the top and bottom by root 65 to clear out the radical in the denominator. And you get -7 roots of 65 over 65. The cosine ratio is adjacent over hypotenuse. So if you're here, 4 is adjacent, hypotenuse is root 65. And you get 4 root 65 over 65 and do the same technique as above. The tangent of the angle is opposite over adjacent, -7/4. Then you do the 3 reciprocals. The cosecant ratio is a HO. It's the reciprocal of this one. This one was O, this one is HO. So negative root 65 over 7. The secant ratio is a funny guy because it's the reciprocal of A. So it is the reciprocal of 4 over root 65, which is root 65 over 4. The cotangent ratio is kind of excited. It says AO, -4 over 7. And hopefully that helps you do 17. Hopefully. So I did pretty much most of the back page except for 17. Yeah, I don't know what to do on the front. Like, I know there's a kid who needs to know how to do number 3. The big deal is we distribute our negative. So we got P's and Q's. That's going to throw some kids off. You have to distribute the negative to all 3 pieces. That's probably the big thing. All right, so there is only one thing with p squareds and q. Nope, there's 2 things. There's that guy and that guy. And 4 minus 9 should be -5. I don't want to look at this anymore. Then I got p squareds. It's just this one. Then there's the pq squareds, and there's just that guy. Now, these are not like terms. P squared, q, p, q squared. And then I got my p's and my q's. 11 minus 7 is 4. That's not too hard. I'm going to kind of save this little grouping for y'all. Maybe I'll do 7. I'll do this first real quick. It's easy. 2x plus 4. Usually I save the doubling for last. Then I'm going to worry about this. X minus 5 times 5 minus x. As I'm kind of focusing my attention on that, I'm going to do the distributive property, double distributive. I'll have a 5x minus an x squared minus 25 plus 5x. Clean that up a little bit. Negative x squared plus 10x minus 25. And then I'm going to invoke the double distributive property. I'm actually going to write this like I have in the notes. I don't know if it's easier or harder. I don't know. don't usually do it this way, but I could see how this would be easier to a kid. You break up 2x plus 4. And you're just showing it because this might make more sense to y'all. We'll have a negative 2x to the 5th plus 20x squared minus 50x minus 4x squared plus 40x minus 100, and then we'll put pieces together. In good old STD form, that is the leading term. That determines the end behavior. Looks like there's 16x squared. Looks like minus 10x and minus 100. And that's where I'm going to stop for this. So sorry you couldn't see the answer, because I'm about to have another class and I have to be done and ready for them.